Welcome. My name is Marco Russo. I work at SQLBI where we produce content about data modeling and DAX for Power BI, Fabric, Analysis Services, Excel. And this training is about, this session is about Power BI Performance Analyzer. My goal is to explain you what you can do with the Power BI Performance Analyzer. Clearly, it's a tool that helps you finding performance issues. We will not solve any performance bottleneck. I want to explain you what the tool can do, because actually every kind of issue then has a number of other details for analysis. And to be honest, the performance analyzer is just the first step to investigate a performance bottleneck. And so my goal is to make you aware of all the features that you have, because then you probably want to use DAX Studio or other tools, or even just the DAX review to investigate more. But it's good to know what you can do with this tool. So with no further ado, let's go to the, this is just a presentation page for what we do at SQLBI. I just have one slide, which is this one that I will show you at the end as a recap for what we are going to see. And let me go straight to Power BI Desktop, where I can introduce this feature. So the idea is the following. Let's say we have a report, right? And a report is like a page in a report. So the report could have multiple pages. We focus on one page at a time. And what happens is that whatever you have in a page is a number of visuals that you have. For example, if I move around this page, you see that we have these simple cards. We're using the legacy card visual, where you can display only one measure at a time. So we have 1, 2, 3, 4, 5, 6 multiplied by almost 6 rows. So it's 36, 33 visuals here, plus this other visual, this another visual, plus this another visual. So there are like 35 visuals with data. But then we also have static strings like this one, this one. These are visuals too. So every visual in the report is a piece of content that has to be, let's say, prepared and rendered by the engine. So what Performance Analyzer does is it enables you to investigate all the objects that are in the page that is displayed to the user. So if you have a report that has 7 pages, you only work with the active page. So other 20 pages that are not visible, they don't matter, basically. So the first step is that, okay, where is Performance Analyzer? Well, Performance Analyzer is in this area. I will zoom in because I have to use a small, I apologize, I have to use, usually I use larger fonts and I increase the font size. But for a number of technical reasons, I have to use, let's say, a smaller font. So I will use the zoom more to show you what, the names or details of particular user interface. So you see that this ribbon, Optimize, that is available here, has this tab, Performance Analyzer, which now is already clicked and corresponds to, I think, this one, right? This is the Performance Analyzer. So if I click here, I open this pane, Performance Analyzer. Now, because I find it not very convenient to go back and forth in the UI, what I usually do, and I go back here, so you see that this is already clicked, but I click 1 and 2 so that it appears finally. So I find it inconvenient that it is enabled by default and then you have to go here, because to be honest, going in this area, I repeat here, and going in this area and clicking here is not exactly, so the icon is small, it's not easy to find, so it's easier to, go here and click twice. Now, you see there is a new pane that at the moment is not doing anything, because Performance Analyzer introduces a sort of monitors what is happening in all the events of the visualization, and it is not active by default. So you want to actually start the recording, and start recording means that, let's say, all the events coming from the engine will be detected and logged here. Now, I'm using Power BI Desktop. And until 1 month ago, Power BI Desktop was the only way to use Performance Analyzer. The good news is that now you can use the same tool in Power BI Service. So you can open Performance Analyzer in Power BI Service. I don't remember if I saved let me check, Power BI Performance Analyzer. I watched this, I prepared this before. Here we go. So I'm showing you the link to the user interface. So this is This is the URL of the current documentation. And as you see now, this is also available in the service. So if I search service, you see that now it is also available in Power BI service. This is a relatively new feature that has been introduced. For convenience, I will continue to use Power BI Desktop, also because at a certain point, if I want to do a few operations, I need to use DAX Studio. And DAX Studio works locally, so actually it's easier. But to be honest, you could use both. You could use the service for the first part and DAX Studio for the second one. Now, what happens when I click Start Recording? When I click Start Recording by itself, nothing happens, right? But what happens at this point is that every time I interact with the report, you will see that there will be rows appearing here. Now there is nothing, but look at what happens. If I click on, for example, this chart, and I select one area, so I select, for example, North America. I click on North America. This action changed all the numbers of my visuals. And this means that I made an interaction with the visual. Now, if I go to this area, you see that cross-highlighted is the event that has been intercepted. You might have other events, like you apply a selection to the slicer, you apply a selection to the filter pane, so you change the filter. And so every interaction, including the full refresh of the page, produces a list of the operations that have happened in the visuals. Every row you see here corresponds to a visual in the report. Let me zoom back. If I click on text box, you see that the corresponding item in the report is highlighted. And this can continue for every object that we have in the report. Now, you see that if I have a text box, like this one, this is just the title of the dashboard. And if I go here, you see that there are several information. So by opening the line that has been logged in Performance Analyzer, we can see the different components that contributed to the execution time. First, the execution time we have here, 84 milliseconds, is the total amount of time that elapsed from the beginning of the action, when I clicked on the chart, to the complete visualization of the report. You see that these 84 milliseconds have been spent by doing two operations. The visual display, which is actually the time to render the visual, to create the graphic and display the content on the visual, and other. Okay, what does it mean, other? Well, as you can notice, there are many visuals in this report. This is intentional because I wanted to show you what happens if we have many visuals. And if you look at that, you see that there are, the execution time is not too bad, but at the end of the day, we have so many visuals that you can imagine we cannot display all these visuals at the same time. So what happens is that internally, the engine has a list of things to do. And when it displays one or two objects at the beginning of the list, the other elements at the end of the list have to wait. And having to wait means that it is waiting. So this other includes the time spent waiting the engine to be able to do something with that visual. You can understand that having three visuals in a report will have a short list of things to do. If you have, like in this case, 40 something visuals in the report, less than 40, something like that, we have a longer things of list to do. And it's inevitable that a few visuals will wait longer. By the way, I'm using a very fast machine. Believe me, if you use this report, which is very simple, very fast. Every visual is very fast. But if you use this report on a notebook that is not very fast, and maybe is running on batteries in power saving mode, it will take much more. And so you see that the other time it takes longer. Luckily, this other time is time that, well, it depends, but in part is spent on the client side, in part also on the back end, which because there are operations running. But so let's say this is the first idea. So we have this list of operation, and my first point is that this other time. So if I go here, and I see this other time, you see that this other time starts to be hundreds of milliseconds. In certain reports where we actually have time spent waiting, for example, for a DAX query, this could be seconds. Imagine you have 10 visuals, and the first two visuals take 5 seconds each. The last visuals will wait 10 seconds, not because they need 10 seconds, but just because they are at the end of the list of the things to do. So sometimes you have this perception that a report is slow because there are too many visuals. And this is the first thing that you can understand from Performance Analyzer. One problem of this visualization, though, and I didn't even start talking about DAX, but one problem of this visualization is that we don't have a Gantt chart for looking at what are the dependencies of this. This visualization is just showing visual by visual a list of the things that have been done for this visual. Now let's move forward. Now I did just a refresh, but what happens if so let's go back here. What happens if I have a visualization that is new? Because so far I used, before starting the session, I made some initial tests, and of course I already, let's say, loaded in cache that the result of several queries. So when we want to actually test, imagine you have a report where the user says, the business user says, oh, this report is slow. What you want to do, you want to run that report with Performance Analyzer, but you want to simulate a situation where there is no cache involved, at least no cache from the point of view of the report. So you see that there is a button here, Refresh Visuals, which forces the refresh of all the visuals without reusing the previous result of another query. Okay, so the idea is that the cache at the report level will not be used at this point, and this is what we usually do. And before that, I will also clear the list because I don't want to see the list of the other events that have happened before mine. So I usually do this clear, and then I click refresh visuals. Okay, so now that I click refresh visuals, if I click on one of these cards, you will see that now there is an additional event. There is an additional event which is this DAX query. What happens? You previously have seen that there were no DAX query involved. Again, because I clicked on a slicer, I clicked on a button, I clicked on a chart, and I reused the result of a previous query stored for the report. But when I do this, it's like when I open this report for the first time, my local cache for the report, the cache for the report is empty, and so all the visuals have to be evaluated. And so at this point, you see the actual request for the value that has to be displayed for this measure in this card. I didn't describe, but you see that there is a measure here for every visual. Every measure has a different filter, and when I click on one of the chart, I change the filters applied. So the engine has to evaluate a different query, a different DAX query for every visual, because this is the current construction of this report. So this means that we can understand how much time has been spent in DAX, and we can clearly understand that, I mean, 11 milliseconds is a good time for a single query, to be honest, because consider there is always some latency involved in just sending a query and getting the result. So we will never see zero, okay? There is always a few milliseconds is the minimum we have to see. And the impact of these 11 milliseconds over the overall execution time of this visual is like 5%, something like that. Which means that it is actually more expensive to display the content of the visual rather than asking the result for the DAX query. And of course, most of the time is other. So we just waited for other visual to be ready and then to start the visualization of this one. So when I look at this report at this point, I already have a very large number of information. First of all, I have many visuals. I see that the time spent waiting for other visuals is the biggest amount of time for most of these visuals. And for each visual, I don't have a problem in DAX. I have potentially a problem for the cost of the visualization of the visual. I'm stretching this a little bit, of course, because usually you don't have so many cards in a visual. But imagine you have a map, and a map has many data points. You might have a slow report because you need too much time to extract the data points and display the data point, sorry, to extract the data points and send the data points to the visual, or the visual itself could be very slow in drawing thousands of data points. That information will be clearly visible here. If the visual has, I don't know, 500 milliseconds, 2000 milliseconds, which is 2 seconds, and the DAX query is just 20 milliseconds, you know that you don't have to optimize DAX. You have to evaluate how to optimize the visual or how to change, how to use another visual that is more efficient. Sometimes the visual is not written well, for example. Now, at this point, though, there could be a case where the query is responsible for a slow report, right? So if the query is responsible for a slow report, we should see this number that is that is bigger. So we will see 100, 200, maybe thousands. Thousands means seconds, right? Because this number is in milliseconds, 1000 is 1 second. What happens if we want to investigate the DAX query? Well, we have two options. You see that we have copy query and run in DAX query view. I start from the bottom. The bottom is easy because I can click this button. And what happens at this point, if I click this button, the DAX query view is open with a new query here. You see that the result of this query is visible here. The query has been already executed. And this is the DAX query that has been sent to the internal engine, the semantic model that is used for this report in Power BI, and the result is the number that has been displayed there. In this case, it's just a number. If we intercept a metric, for example, or a line chart, we will see a list of data points that are displayed in the visual. At this point, though, if we have a performance issue, we don't have much we can do just in Power BI, desktop or service. Because in Power BI, we don't have tools to investigate the actual execution time. So chances are that you want to run the same DAX query in a tool like DAX Studio connected to the same semantic model. For example, if I click on external tools, I have DAX Studio installed here, you see, as an external tool, and I click on DAX Studio, and if you're using Power BI Service, you can run DAX Studio and connect DAX Studio to the same semantic model you have in Power BI. Then you paste the query, and so let me go back 1 second. So if I go back to my report and I click on this button, copy query. Oh, sorry, no, I click on the right button, sorry. I click on this button, copy query. I copy the same text in the clipboard. Now I switch to DAX Studio and I paste the code here. I click at Ctrl V, which is like a right click and paste. What happens at this point, this is the same query, but now in DAX Studio we have tools that we can use to analyze the query performance. So now I am quickly I enable the visualization of the query plan, the visualization of the server timings, where we have information about the internal execution. And we can use this information to understand what to optimize. As I said, the goal is not to discuss this in this session. I want to understand what I can do with performance analysis. So performance analysis is a starting point where I can investigate, okay, what is causing performance lowness? And for example, imagine that you have some, but not all, of the visual that are slow in DAX. One thing we can do, and I go back to Power BI, you see that there is a sort order here, and this click here can enable me to choose how to sort the information I collected from a performance analyzer. Now this is just an action order, the list that is received from the visual. But I could say, well, I want to sort these visuals by total time, and remember, total time is the total waiting time, including the other. And by total time, usually you choose descending. So you get the slowest visual first. And you see that the slowest visual is the matrix, but the slowest visual is the matrix, not because of the DAX query. Look at the DAX query. The DAX query here is just 6 milliseconds. Come on, this is very, very fast, very efficient. The problem is that it waited for 222, no, sorry, it waited for 126 milliseconds, other visuals, and then it spent 242 milliseconds just to display the matrix. Okay, so, well, the matrix is the slowest part here, not DAX. Now, these are very good time, very good execution time. I'm not worried about that. But imagine that you have 500 or 2000 for the DAX query, then you want to analyze that. That said, you see that there is a problem. It's not I cannot make the assumption that the slowest visual is the slowest one from a DAX query standpoint. So what I usually do, I sort by DAX query execution time because I want to optimize DAX. And so I sort by DAX execution time, and I see that now this is the slowest one. Again, we don't have a real problem here, but sometimes you discover that the slowest DAX query is not the slowest visual, but in a way it affects the other visual because it increases the waiting time of many other visuals. So this is the first trick I wanted to explain to how to use this feature in an efficient way. Now, the last element I want to show about this tool is that the way this data is displayed sometimes is not very efficient, I would say, because I would like, for example, a Gantt chart, or I would like to ignore the other time. Now, there are a number of other information that are collected and are not displayed. So this other time is a decision that the user interface of Power BI Analyzer does, but in reality is not a collected information. It's just a measure of the distance between the start of the execution of the page and the start of the execution of the visual. And we can export, you see that there is a button export here. We can export a JSON file with all the data that has been collected. Let me show you. So if I go back here, so if I click export, I can save this into a file, right? This, for example, optimizing card visual and so Power BI reports. So I type 2. So I'm just providing a name here, and I click OK. I click save. So what happens at this point? Let me open this file quickly by just using an editor. So let's see if I can have Visual Studio Code for that. 1 second. Here we go. So this is the JSON file. Okay, I could just format it in a better way, but it's just a long text file with a number of information, right? The good thing is that if you want, you can import this file in Power BI, in another Power BI report, which is what I did. So you can see that I have another file here where I imported that file, and I display that file by showing all the individual events that are collected by Performance Analyzer. Performance Analyzer collects a number of detailed events that are not exposed into the user interface of Power BI Performance Analyzer in Power BI Desktop or Power BI Service. For example, you see that other than the execution of the DAX query, we had this execution of the semantic query, which is the total of these two elements, execute query and execute DAX query. So we enter into technical details here, but you imagine the DAX code has to be prepared. And so there is a time also spent to prepare the query, and then the query has to be executed. This is the query generation. There are many other details that are described here, and this is the ID of the visual. So you can see this is the total execution time of that query for all the visual in this report. So I think that actually execute query is the actual time for analysis service for the DAX engine, and this DSE is the layer on top that converts the semantic query described as an object model into the DAX code that is sent to analysis services, whereas the query generation is just the generation of the object model that is the semantic query that is sent to the engine. So this is an internal list of architecture. I will give you a link to a document that explains these details if you want. And you see that the render time is actually the slowest amount of time. So, for example, how did we optimize? So when this is an information I don't have in the visualization of performance analysis. I'm just aggregating all the display time. I want to say, okay, what is the total amount of time to display this page? Just for display, 1 second and 300 milliseconds. So what we did, for example, in this model, we converted this using another visual, which has in a single visual multiple cards. Like if you use the new card visual, you can do something like similar to this. In this case, I used a custom visual, which is called card with states, which allows you to create multiple cards with the same style using the same measure with different categories or different measures. And this is what we did. Now, if I clear this and I refresh the visual, you see that we have a much smaller number of events because we have a much smaller number of events. The result is the same from a visual perspective. And when I look at the total amount of time spent and I open the Power BI file where I prepared, I hope Power BI file where I prepared, where I imported the execution of this one, card states. I imported the JSON file obtained from a performance analyzer for the page that I just shown. I imported this with Power Query. I created this visualization, and here we go. You see that we lowered the execution time to 764 milliseconds instead of 1 second and 300 milliseconds. But more important, we actually lowered the execution time of the entire DAX query. Why? Because we have a lower number of DAX queries, and so we save time because we have a lower amount of time spent then. Now, this format can be used in Power BI Desktop, importing the JSON file, or the last thing I want to show you is that in DAX Studio, we have a tool, this load perf data. Okay, let me show you this again. So if I go here, load performance data, this is a tool that we created to import the file exported from Performance Analyzer. And when you open this, you have a specific tab here. You see PBI performance, where you see the data that is in a JSON file, just in a table, like in an Excel file. And the good thing here is that you have the exact starting point, ending point of each visual in the report, and you have the query time, the render time, and the total. We don't have other here, which is sometimes helpful because actually we don't want to see this other time that is confusing. And finally, you can double-click one of these elements to see, let me clear this. If I double-click one of these elements, I can see the query that has been saved for the execution of this visual and a number of other details that are otherwise not very visible. So the comment of the query has a detailed list of all the other properties, render time, query time, duration, start time, and so on, that can be very helpful when you do some investigation. So I think we are at time. Actually, I'm consuming more time than I'm allowed, but let me go back to the slide 1 second, and I want to give you this recap of the information that we have seen. So Power BI Performance Analyzer is useful to get a first look at what is causing at the bottlenecks you have in a report. You have more details about the timing because we have the data shape engine, DSE, which is the semantic query that then generates the DAX code. You have the data model engine, which is written in AES in the JSON file, which is the DAX query execution time. And the report canvas, RC, is the time to render the visual. The information about this the spec of this JSON file are on GitHub in this documentation. This document, docx, you see that there is a, if you go to Microsoft Power BI Desktop Samples, Performance Analyzer, Power BI Performance Analyzer export file format docx, if you download this Word document, you have the description of the format. You also have the schema in JSON and also an example that allows you to import this file and show something similar to the report that I shown you in the example. And so I think that this completes our very, very quick look at the Performance Analyzer. I don't know if you have any question, if we have time. So I'm reading the question. Isn't the action in Performance Analyzer based on selection pane order? Not sure about that. So the question is the list of the events the list of the event corresponding to the selection pane order? I'm not sure about that. Potentially no, I guess, but I'm not sure. And if you order the Performance Analyzer again based on action order in the non-optimized report page, why did the text file lower other time than the car visual? Again, it depends on the sort order. I don't know at which time you displayed it, but you asked that. But the idea is that you can choose the sort order, but I'm not sure that the action order makes sense. So because I don't think it corresponds to the other. Thank you.